Hello wonderful person, this is Anton, and today we're going to be talking about one of the recent papers that might have resolved one of the older mysteries in regards to our neighbor Mars. Why exactly is there no magnetosphere on this planet? Or to be more exact, why is there no more magnetosphere on Mars? Why did it disappear a few billion years ago? And in this particular case, the study is extremely interesting because they might have actually solved this particular mystery by creating an analog using the materials on Earth and using something we refer to as a diamond anvil, something we're going to be discussing in a few minutes. But first of all, why do we want to know this? Well, the main reason is because we believe that the loss of magnetosphere resulted in Mars becoming uninhabitable. It lost its water, it lost its atmosphere, with the Sun being responsible for doing all of this over the period of possibly a few 100 million years, maybe a little bit longer. And so it turned into the planet that we know today, the planet that basically doesn't really have much on the surface. But we also want to understand if something like this could one day happen on our own planet, or more importantly, if we start finding all of these exoplanets out there, and some of them might have magnetospheres, while some don't, we want to understand what exactly happens to these planets and what kind of protection the magnetosphere offers to those planets. But I guess generally we also want to just understand how exactly do these fields form, how they interact with the environment around them, and what are the most important components that create the field that then protects our planet from turning into something a little bit less hospitable. Although saying that Mars doesn't have magnetosphere anymore is not entirely correct. There are still weak remnants of the ancient magnetosphere that existed here that you can kind of see on this map right here, that sort of creates the electric fields that are still visible and detectable even today. We've discussed this in one of the previous videos, you can find somewhere right there or in the description. But these are just remnants, and these are very likely produced by some of the magnetized materials on the surface. So it's not an active magnetosphere produced by something that's churning on the inside, similarly to what we believe happens inside planet Earth. Which is also why the magnetosphere on Earth is much stronger and is able to protect the planet from a lot of different types of radiation and a lot of other potentially dangerous effects that could strip the planet of its atmosphere. So for example, we know that the convective currents inside the planet that generate all sorts of motion, rotation, and all sorts of patterns because of the rotation of the planet and the Coriolis effect end up creating the magnetic lines that then protect the planet. But in this case, it obviously requires something that's able to conduct electricity and essentially something that's metallic. And so it's believed that all of this is very likely produced by some kind of an alloy of iron, and very likely iron mixed with nickel, potentially also containing sulfur and oxygen, creating a somewhat unusual and somewhat mysterious substance. The actual details are still being studied even today. But then on other magnetic objects like Jupiter, Saturn, Neptune, and Uranus, it's also something metallic, although in this case it's highly pressurized and relatively hot hydrogen. And so hydrogen under pressure and under high temperatures also becomes metallic and starts to produce very similar patterns, producing magnetic lines, producing the magnetosphere on these planets as well. And so you definitely have to have high pressures and high temperatures to maintain the magnetosphere for a pretty long time. And so for many years the scientists believed that, well, maybe Mars just sort of either cooled down or was just not massive enough to produce enough pressure and temperature to maintain the magnetosphere for a pretty long time. But this explanation didn't really sit well with everyone, mostly because it didn't really explain why exactly did the magnetosphere stop, or why was it even working in the beginning. So something here didn't really add up. And so some of the previous studies on meteorites that came from Mars and landed on Earth established that for the most part, first of all, the molten iron that's present in Mars, or was present in the beginning, very likely is also enriched in sulfur, so possibly kind of similar to planet Earth. But further investigations, specifically from probes like InSight that you see right here, discovered that the core on Mars seems to be larger in size than initially thought, and thus seems to be less dense. Or in other words, something inside Mars is decreasing its density, with that something being some other material, and specifically the scientists believe it's very likely hydrogen. Although technically it could be any other light element, but hydrogen here makes the most sense. It's the most common element. We also know that there is already quite a lot of hydrogen on Mars, and so it just sort of adds up. Obviously it could be something else, but for now hydrogen seems to make the most sense. And so the scientists behind the study, you can find in the description, kind of went with that idea. They realized that it could be some sort of a mixture of iron, sulfur, and hydrogen. And so they decided to use some of the most advanced technology to recreate the potential environment where this particular alloy can exist, just to see what would happen to this alloy in these conditions. So they took this iron, sulfur, hydrogen alloy and used the so-called diamond anvil, also known as the diamond anvil cell. And essentially the way it works is that you'll have two different diamonds on both sides, mostly because of the strength of the diamond as a material, and then by placing something in between the diamonds and squeezing it extremely hard, you can essentially create extreme pressures similar to the ones inside a typical planet. And then by also applying lasers to this, you can change the temperature, creating extreme temperatures and pressures. And so they try to create the conditions inside early Mars. Basically pressures and temperatures that would be kind of similar to Earth, but maybe a little bit lower. With this particular study being the first to also introduce hydrogen in there. And by the way, water in this case would be an excellent source of all of this hydrogen. It could have been deposited into the planet and could have stayed there for a long time. And then they essentially observed how all of this material would behave in these conditions by using the X-rays to try to trace the motion of material. And well, they discovered something somewhat strange, and actually a word that is also somewhat strange and most of us are probably not familiar with. They discovered that the material resulted in what's known as immiscibility, which is the opposite of this word, miscibility. One way of trying to understand what this means is basically looking at oil and water. It doesn't mix, it creates two separate, slightly different substances. And so by definition, immiscibility refers to the idea of these substances that are not homogeneous, they're not mixed well. And it looks like this immiscibility could actually be the explanation for why the Martian magnetosphere disappeared. Because when they made the substance, when they pressurized it and made it very hot, eventually with time it started to display immiscibility with both substances separating into two different areas. This figure right here sort of shows us what might have happened. So for example on Earth, even with time, only a very small part of the actual outer core is going to become immiscible. And it's mostly going to be somewhere right here on top, with the vast majority of space still dedicated to this homogeneous substance that circulates, creating the magnetosphere inside. Yet on Mars, something different happens. With time, these substances separate and create a very specific boundary. It doesn't happen right away, but it does happen within approximately a few 100 million years. And though initially there was definitely very similar activity in one of the parts of this particular substance, very similar to planet Earth, eventually as the actual substances divide, creating the so-called sulfur-poor and sulfur-rich liquid, they eventually create a boundary that sort of stops the activity inside the planet, or stops the fluid convection currents that create the magnetic field. And so once these two liquids separated, that's when the magnetic field stopped completely. And at the moment, this is honestly one of the best explanations we've ever heard about what might have happened. And at the same time, this also puts an end to that silly idea someone proposed back in the days, that you could somehow recreate the magnetosphere by basically putting a bunch of nukes inside Mars. In this case, the immiscibility is not really going to help us at all. The actual substances are still going to be separated from one another. And that of course means one thing, and it's something that we've actually discussed in some of the previous videos. It's something to do with the composition of planets. The minerals that are present inside a planet are extremely important for maintaining both habitability, but also a lot of other properties. For example, the fact that Earth still has water is actually because of the certain minerals present on the surface that seem to be absent from a lot of other objects. And here we're talking about just the right composition of different mixtures that create things like, for example, the mineral olivine and all its derivatives that then allow the planet to store water. At the same time, the minerals inside the core seem to be also responsible for creating just the right properties for maintaining the magnetosphere. The properties that are just not present on Mars. And this particular idea goes beyond our solar system. It means that, let's just say we found some kind of an exotic terrestrial planet. I don't know, let's just say this planet right here, known as Kepler 442b, that many scientists in the past have referred to as more habitable than Earth. So a super habitable planet. Well, in this particular case, we don't really know what's inside the planet. We don't really know what minerals it contains, and because of this, it's going to be practically impossible to find out if this planet can at all maintain similar conditions to planet Earth. So if it had extra hydrogen, if it had extra sulfur, the actual conditions could have changed completely. For all we know, it could be some kind of a hellish world like Venus. Which means that this particular discovery is super important, once again confirming that minerals are everything. And once again confirming that Earth could be unique after all. But we'll actually discuss more about what we've discovered from Mars and planet Earth in some of the future videos, so make sure to subscribe, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Maybe support this channel on Patreon by joining a channel membership, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.